R3. There is no way that it gets divided. Okay. Now let's say I connect a resistor R4 here, and it is somewhere connected with the other things here, which we are right now don't know about. Now, if I say R1, R2, and R3 are in series combination, will that be a true statement?
No.
No. The reason behind that, because
Current is getting
right
divided.
now, yes, see, we should never make a statement that current will get divided. We don't know about it. Okay, there actually, what we should say here, that there is a possibility of division of the current. Whether
Oh,
it
okay.
will get divided or not, we are not sure about that. That we'll get to know if we'll see the complete story, if we'll see the complete picture, only then. Okay, let me do another thing. Let me make it like this. Now tell me that R1, R2, and R3 are in series or not?
Yes.
Yes, they are. Because at this point, I had connected a resistor. But do you think that is there any current going to flow in this branch? The answer
No.
is no. Because current always flows in a closed loop. Okay, understood?
Yes.
If the current is moving, so it will definitely come onto its initial path from where it had started. So just by joining the resistor, I cannot initially make instantly make the comment that the current will get divided. Maybe the current will get divided, or may not it will get. Okay, so if I'm making the circuit somewhat like this, so I had connected some circuit over here, which I am right now don't know about, but now I can definitely say that R1, R2, R3 are not in series. Okay, so these things is the something that how we used to see that whether the resistors are in series or not. Okay, the next thing, yes, and one more thing, that R equivalent in the series. In series combination, it used to be the simple addition, R1, R2, R3, and so on till whatever it is. Okay, we had taken only three resistors, so I'm writing only R1, R2, and R3. Yes, sorry. Let's move on to the another thing. How to detect whether the resistors are in parallel combination or not?
Oh,
Potential
current
difference.
across them is different.
Yes,
And
not really. That the current is different. That does this give us the reason that we used to say that this is in parallel?
voltage across them is same.
Yes, we used to say it like if they are connected across two same points, that is the two same node. If I had made a point here, and whatever the resistors are connected in between these two will be treated in parallel combination. The reason behind that, because they are having the same potential difference across all the three resistors. Okay. Yes, Rijan, tell me what is the use of this battery?
Oh, you do the battery. Oh
Yes,
yeah.
5 volt battery. Yes, what it does?
To see the potential difference throughout the
Of
circuit.
5 volt. Okay,
Mm.
so establish a potential difference of 5 volt to across whatever whichever these 2 points will be get connected. It will establish a potential difference of 5 volt across those 2 points. Okay, to whichever this point is being connected. We don't know about that where it is being connected. If it is connected one over our head, another over our toe, so there will be a potential difference of 5 volt between our head and toe. Understood? It doesn't
Yes, sir.
matter that where it is being connected, but one thing it will guarantee is that it will always establish a potential difference of 5 volt. Okay, does this give us any guarantee of the current, that how much current is going to flow?
No.
No, it does not. Okay, current could be anything. Okay, so this is
Yes.
something that you should know about. Okay, it's a very small thing, but let me tell you over here only in the recap part. Like if I draw a current versus voltage relationship of a V battery, okay, that is a potential difference of 5 volt. If I'm drawing, I want to draw the I versus V curve. So what do you think that how should the curve look like? Yes, both of you.
Well, linear, right?
Yes, it will be a linear, but linear could be of any kind. Like it could be of like this, it could be like this, it could be like this, it could be anything. It could be like this, it could be anything. But how it is going to be?
Whereas current increases, voltage will also increase.
Yes, Rijan, do you believe with this statement that does the potential difference is going to change?
Yeah. No. No. If the
No,
voltage
sir,
increases,
actually,
then the current increases.
VAB. Okay, yes.
Yeah, if the voltage increases, then the current will increase.
First of all, tell me, is voltage going to increase across the points A and B?
Over there, no.
It will always remain same, 5
no,
volt.
but current can increase, right?
Current can go
So
anyway.
it's not, that's true, then the statement is.
Okay, so current can go anyway, but the potential difference is going to be the 5 volt. So curve will look somewhat like this.
Oh, fine.
Like current can take any value, but the potential difference will always take a value of 5 volt here across the point A and B. It is not going to change. Understood? Is this clear to you people?
Yes, sir.
Okay, so just take care about these things. These are one of the very crucial things. Like I had not told you explicitly about this, just include it in your notes. Okay. Yes, the next part in the lecture we had seen the voltage divider rule. Voltage divider rule. Okay, what is the voltage divider rule? Like whatever the resistors we have, somewhat like this. Let me take three only this time. And if we connect a 100 volt, okay, let's say we are taking a 100 volt here. Oh, let me take another value because previously I had taken the 100 volt, 10 ohm, 15 ohm, and 20 ohm. Okay. So if I want to know about this potential difference V1, V2, and V3, V1, V2, V3 are not potentials, they are potential difference. Okay. One potential, a point of one potential minus point of another potential. Okay, so they are the potential difference, not the potentials. Now, if I want to know about the V1, how should I do? What should I write here?
It will
Or
be
120 into V1 by total resistance.
120 by, in how many parts I'm dividing this potential? 10 plus 15 plus 20. And
Yeah,
how much part of it do I need to give to 10? That is the 10.
V1. Yeah. Oh,
Okay, not V1, that is 10. That is the V1. The next V2 is, I'll again develop the same one unit, that is 120 by 10 plus 15 plus 20. And how much part of this unit I want to give to 15? That is this 15. Okay, the next is V3. Again, the same thing, 120, dividing into the same portion, that is 10, 15, and 20, and just multiply it with the, that is this time 20, because I'm providing it to the 20 volt. Okay, so this is something that you should know about. And here was the end of our class where we ended up everything. Okay, so this was the voltage
sir.
divider.
By the
Yes,
way, that was for potential difference, right? Difference with
yes,
2 points.
exactly. This V1, V2, V3 are the potential differences. If you want to
Yes, sir,
write
yes,
it
sir.
explicitly, you should write it like, let me make the points A, B, C, and D. In place of V1, what you should write? VA minus
VB.
VB.
VMS
Because
VB.
VA is the higher potential, VB is the lower potential. In place of
Yes, sir.
V2, what you should write? VB minus
VB
VC.
minus VC.
And in place of V3,
VC minus VB.
yes. Okay, so if you want to write it explicitly, you can write it in this way. But this is the marking that I had shown just by doing like this, that I'm calculating the potential difference. Okay, and remember this, in our whole physics, whenever we talk about the potential, it is like we always talk about the potential difference. Potential does not give us any information. Okay,
Yes, sir.
the only information that we use to get, or we use while calculating anything, is always the potential differences. Okay,
Yes,
sorry.
sir.
So this is something that we are going to do. Okay, let me write this in the note point, that let's say that if we have the two, because in most of our cases, we'll see the configurations to be made for the, or the points are to be calculated for the two resistors only. So I'm explicitly writing it for the two. Okay, let's say if V, this is R1, this is R2, and let me make some point that this is the potential difference V1, this is the potential difference V2. Yes, what will be the V1 here? Yes, Rijan?
oh, uh, V by R1 plus R2 into R1.
Yes, exactly. Okay, this is the one unit that I developed multiplied with the R1. Yes, Ahil, what will be the V2 here?
V by R1 plus R2 into R2.
R1 plus R2 into R2. Okay, so this is how we'll write this. So, okay. We can do so, and this is something that we had seen over here. Now the next thing is, that is the current dividing. Now we are going to see the current dividing rule. What is now going to be? See, previously for the voltage divider, how many resistors were there in the series configuration?
Uh, uh,
Three,
for
four.
this case, right?
Okay, like for how many we can define it in such a way that we are doing.
Sorry, what? Can you repeat, sir?
See, previously we were defining the voltage divider in this fashion, that we divided by how many resistors are there into
Yes.
R1. Okay, so how
Yes.
many resistors can we have in our configuration?
You have
Possible,
As many as we can, right?
as many as you
as
can,
many
right?
as we can.
Yeah.
Okay, as many as we can. There was no restrictions over it. Okay, but
Yes.
uh, okay, let me do it over here. Then you will see the problem, and then okay. Okay, so let's have this R1, R2, and R3. Okay, this time what is our aim? That we want to divide the current. If we want to divide the current, that means we are initially having the information about the current. Yes or no? Previously,
Yes.
we were dividing the potentials. So we were having the information about the total potential. And based over that, we were calculating the potentials, the potential difference of the individual resistors. Now the same thing is going to happen, but this time what we'll have the information about the total current I. Okay. Now some of the part is going to pass through R1, some of it will pass through R2, and some of it will pass through I3. That is in R3. Okay, now our aim is to calculate these I1, I2, and I3. Okay, in terms of I and R1, R2, R3. This is our aim. Okay, so how we can do so? Let us see. If this is the point A and this is the point B, so can we replace this R1, R2, R3 by the single resistor?
Yes.
We can replace so. Okay, let me make it A, B. Okay, what it will be called? It will be called R equivalent. Yes or no?
Yes, sir.
Yes.
And we can calculate this R equivalent by 1 by R1 plus 1 by R2 plus 1 by R3. Yes or no?
Yes, sir.
We
Yes,
can
sir.
do so. This is the problem. Oh, this is our actually something that we can find out very easily. Okay, can we calculate the VAB over here?
Yes.
Yes, what it will be?
So total
I into
will be,
R equivalent.
I
yeah,
into R.
R equivalent.
Okay, so because the same current, whatever the above I was there, is the same current going to pass through here also. Because if we are replacing by its equivalent, the circuit parameters are not going to change. Okay,
Yes.
because if the circuit parameters are changing, we are very inefficient engineer to do the substitution, and we had done it in a very wrong way or bad way, that it is changing the circuit parameter. So we don't want it. We will substitute it in such a way that we'll get the VAB, that is I into R equivalent. Okay, this VAB is the potential difference across these 2 points, yes or no?
Yes.
Yes, sir.
And this VAB is the same potential difference across these 2 points as well. Because repeating the
Yes.
same old story, that the circuit parameters are not going to change. Okay, so VAB is this. Now tell me, if I want to concentrate over this I1, so do I know the potential difference across this R1? That is VAB, the
Yes.
same VAB, yes or no?
Yes.
Yes.
The same VAB, that means if I want to calculate this I1, what it will be? The VAB and whole divided by R1 using the Ohm's law again and again. Okay,
Yes.
yes or no? And
Yes.
what it will look
Yes.
like? That I into R equivalent divided by R1. Yes or no?
Yes.
Yes.
Now you can write the same thing, VAB by R2. And what is VAB again? I into R equivalent divided by R1. Yes or no?
R2,
Yes.
right?
Oh,
Uh,
R2 I mean. Yes. and I3 will be VAB by R3, and that will be I into R equivalent by. Yes or no? And if there is the n resistors, I can define it for the n as well. Yes or no?
Yes.
Sorry. So we found that. Okay, but don't you think that this is not as easy as the previous one case was there? Here we this portion calculating this portion is looking very easy, but mind you that for to calculate these things, we already should have the information about the R equivalent. Yes or no?
Yes.
And
Yes.
that R equivalent is found by this particular expression, which is not a very nice one. Yes or no?
Yes. Yes.
Yes.
Previously, what was happening? We can intuitively see that there was 100 volt. We are dividing it among all the one, and we are creating the one unit, and then we were providing it to the separate resistors. Yes or no?
Yes, sir.
But this time, what is happening? That I think I can see a one unit like I into R equivalent. I can see it as the one unit as I into R equivalent, and divided by R1 in the second case, divided by R2 in the third case, divided by R3. But this I into R equivalent in itself is not a very good expression. Yes or no?
Yes. Yes.
So
Yes, sir.
that is the reason that why we don't use this a lot. That is called the current dividing for the many resistors. Let us do this for the two resistors as only. Okay, if only two resistors are there. Okay, let us say that if there is only two resistors, if there is two resistors and the again total current I is going through it, what is the current through I1? This is I2. Let me name this as R1. This name is R2. Now let us calculate I1 and I2. Okay, first of all, can you people tell me that what is the R equivalent here? Calculate it in
One.
terms of R1 and R2.
1 by R1 plus 1 by R2.
Yes, do the complete calculation
Oh,
and tell
okay.
me what is the value of R equivalent.
Point.
That will be like what? R2 plus R1 upon R1 into R2.
Yes, it is R1 into R2 whole divided by R1 plus R2. Can you people see this now? Because I am going to use this formula also while doing the calculation. So you must be very comfortable with this one. Whenever the two resistors are there, I don't prefer to write it like 1 by R equivalent to be 1 by R1 plus 1 by R2, and then taking the LCM to be R1 into R2, and then cross multiplying the above things. I'll get R1 and R2, and then just inverting it, so I'll get this expression. Okay, so I used to save my time. Instead of writing these four steps, I used to directly write it as R equivalent to be R1 into R2 divided by R1 plus R2. Is this clear to you people?
Yes, sir.
Yes.
Yes. So because I'll use this in a very fast way, so just be with me for that. So I1 is there. Let us calculate the I1. What is I1? I into R equivalent whole divided by R1. Yes or no?
Yes.
Uh, Let me write it again. I into instead of R equivalent, I can write it like R1 into R2 divided by R1 plus R2. Yes or no? And whole divided by
Yes.
R1 was left. Yes or no?
Yes, sir.
Yes, sir.
Just cancel out the things. What will get I1 to be here? I1 to be I divided by R1 plus R2 and multiplied with the R2. Yes or no?
Yes.
And just calculate the things for I2 and tell me that what will be the final expression.
It will
Uh,
be I
I
R1 by R1 plus R2.
here.
Yes, I into I whole divided by
R1 plus
R1
R2
plus
Uh,
R2
to
into
R1.
R1.
uh,
Yes or no?
yes.
I'll get this expression because what I need to do, just in place of R1, I need to, I'll write R2 here. So this time R2 will be cancelled out and R1 will be left in the numerator. So this is the expression. And this gives me somewhat a good feeling. The reason behind that, see, previously there was voltage and I was dividing among it R1 plus R2 plus R3. And whenever I need to calculate the potential difference across the one, I need to multiply that resistor with that particular one unit. Okay. This time, what is happening here? That when I need to calculate the I1, when I need to calculate the I1, I'll multiply the R2. And when I want to calculate the I2, I'll multiply it with the R1. And this is very obvious thing. Just tell me one thing, that don't you think that current is inversely proportional to the resistance?
Yes.
Yes.
So that is why this is having the inverse relation. That is I1 is, if we want to calculate the I1, we are multiplying the R2. And if we want to calculate the I2, we are multiplying the R1. Because higher the resistance, lesser will be the current in that branch. Yes or no?
Yes. Yes, sir.
Okay. So let me give an example to you for that. Let's say 100 ampere current is coming here. Let's say 20 ohm is this and 40 ohm is this. So if I want to calculate this I1 and I2, what I'll simply do, I1 to be,
100.
how much current do I
100.
have? 100
100.
divide by the total number of
60.
resistors, that is 20 plus 40. And if
Mm.
I'm calculating the current in the 20, multiply the opposite resistor, that is the 40. If I want to calculate the I2, how much current do I need to divide? That is the 100. In how many of them? That is 20 plus 40. And this time I'm calculating the current in the 40. So I'll multiply the reverse one, that is the 20 over here. Is this clear to you people?
Yes, sir.
Yes, sir.
This is how we used to calculate the things. And while doing this calculation, I don't require anything of the R equivalent or anything else. This is the good thing about that. And this gives me a similar feeling like I was doing there in the voltage divider. Is this clear to you people?
Yes, sir.
Yes, sir.
Sorry. So this is something that how we used to apply the current divider and the voltage divider. Understood?
Yes, sir.
So, sir, current divider won't work on three resistance. It will only work on two resistor. Or...
It will work for n resistors as
Yes.
well, but for the n resistors, you have to apply this formula. I into
This
R
was.
equivalent by R1. Okay. If you will go through this thing, so that is why I recommend not to remember this particular one, that is I into R equivalent by R1. Always remember this one, because we'll always apply the current divider in particular for the two resistors always.
Okay.
Okay. It is valid for the n also, but for the to do the n, I had told you about all the old story. I have to repeat it again.
Mm.
See,
No.
like, you have to go through this process. For calculating this I into R equivalent, you should know about the R equivalent. That will come from this particular expression, which is not a very good expression here. Is this
Yes.
clear to you?
Yes, sir.
So that is why we will always apply the current divider for two resistors always in most of the cases. Understood?
Yes.
Okay. Let us do a question over here. Okay. So let me make the circuit somewhat like this. And let's say that this is a 60-volt battery. Okay. This is a 60-volt battery. Okay. Understood? Is this clear to you people? Is this circuit clear to you
Yes,
people?
sir.
Okay. I can ask a lot of things over here. First of the thing is R equivalent R across AB. Okay, which you can very easily you people can calculate it.
Yes.
What will be the RAB here?
Sir, final answer or
Yes, final answer.
okay, I will. So will it be 20?
it will be 20. Okay, how we have to do this? See, 10 plus 20 are in series and they are in parallel with the 20 plus 40. That is the lower resistor. Yes or no? Yes, Rajan, is this clear to you?
Yes, sir, got it.
Okay, so what it will be? It will be 30 parallel with 60. If 30 is parallel with 60, 30 into 60 whole divided by 90. Okay, that is 30 plus 60. Okay, and it will be 30 into 60 whole divided by 90 and 31, 3, and it will be 21. Okay, is this clear to you?
Yes.
Yes. If this is clear to you, okay. If I mark the sum of the points, okay. So let me do it over here. Let me mark this point to be C and this point to be D. Okay. See, if I fix a potential of any point in the circuit, then I can even mark the potential of the another points as well. Okay. How so? If I fix the potential of this point to be 0 volt, so what will be the potential of this volt?
60.
That will be 60 volt.
60.
Okay, so because the battery establishes a potential difference of 60 volt, so that is going to go through this particular thing. Okay, one more thing, that sometimes for to show the 0 volt, we used to make it the ground like this. If a figure somewhat like this is made, that will also be the same. That means that that point potential is 0 volt. Is this clear to you, people?
Yes, sir.
Okay, sometimes what happens that instead of the above figure, somebody comes and gives us this figure. Somebody comes and gives us this figure, and this potential is marked as 0 volt. So can you people see that I had drawn the above same figure to be like this? This potential, the lower part of this battery was at 0 volt. I had made it at 0 volt. This another point of the circuit, that was the point B, I placed it with a 0 volt, so that is looking like this. So is this clear to you, people? This doesn't mean that this circuit is not closed. This circuit is still closed. That means uh, this 0 volt and this 0 volt are the same potential, so you can actually join that 2 points. Is this clear to you, people?
Yes, sir. So
Okay.
current will flow, right?
Yes, current will flow. Okay, you should not like sir, this is disconnected one. So how is the current going to flow in this circuit? It will flow because this is actually the ground that we had replaced the
Yes.
ground.
Yes,
Ground
sir.
just means that is the 0 volt, and we can actually join these 2 points. We can actually join these 2 points. If you are not comfortable with that, join these 2 points and apply all your analysis. Everything will be fine with that. Okay. So this is something that we had found out. Okay. In the above circuit, if I move through this particular thing, can I see that these through 10 and 20, they are in series actually? Can I see this?
Yes. Yes,
They
sir.
are in
Yes, sir.
series. So can I apply the formula for the voltage divider here and calculate the potential of C point?
Yes.
Okay. So potential of C point. Yes, Rian, tell me that how should I write the potential of C point?
60 divided
Like
by
I want to calculate not C point, I want to calculate the potential difference of the AC point. Okay, so what it will be? That is 60 divided by,
R1 plus R2. I mean, like 10
that
plus
is,
20.
yes, this time these are 10 plus 20. And how much part of it should I give it to the 10? That is the 10 of it. Yes or no?
So you wrote
Yes.
VAC. Was it
Yes,
AC?
I'm I'm writing the potential difference across these two AC.
Oh, okay. Yes, sir.
Okay, so VAC, that means the potential difference across AC. That simply means VA minus VC. That
Yes,
simply
sir.
means VA minus VC. Okay, so this is something that I had got. What it will be? 60 whole divided by 30 into
Will
10.
20.
It will be 20.
20.
Uh, yes, it will be 20. Okay, is this clear to you?
Yes.
Yes.
If the potential difference across these two is 20 volt, so what is the potential of C point?
20 only.
Mhm.
No. No, no, no.
So what?
Wait.
Repeat the question. I will help you.
If the potential difference across the 10 ohm is 20 volt, so what is the potential of point C?
Uh,
Can you people see that this whole line is at 60-volt potential?
Yes.
Yes or
yes,
no? I had fixed the one of the potential here has to be 0. So this potential is 60. So this A point potential is also 60. Yes or no?
Yes.
yes.
And if I move from A point to C point, I get a drop of a 20 volt
So it'll be 40.
because
Let's see.
yes, because it gives a potential difference of 20 volt. So what is the C point? That is 40 volt. Is this clear to you people?
Yes, yes.
Okay.
Um,
Tell me what is the potential of B point?
B
no.
point. Let's see.
That is
0. Mm.
0 volt. Okay.
0
So
volt.
what is the potential
Yes.
difference across 20 ohm?
40.
40 volt. Okay. You can calculate this using the voltage divider as well. If you want to calculate this VCB this time, yes or no? What it will be? 60 divided by 10 plus 20, multiply it with this time 20, yes or no?
Yes.
Yes.
So if we'll do so, what we'll get? 60 divided by 30 into 20. Am I getting the 40 volt same?
Yes.
Understood? So this is how you can do so just by manually calculating the things. Now the same thing in the lower branch. This time I'm talking about the lower branch. So if I move from point A to point B, I'll get a drop of a 60 volt. Yes or no? If I
Yes.
move from this point to this point, I'll get a drop of a 50 volt, 60 volt. Let us calculate the potential, the VCD this time. This time VAD, sorry.
80.
Okay, VAD. So if I calculate the VAD, what will
20.
I do? 60 divided by this time 20 plus
20 plus
40.
1. Yes.
So it's 20.
So 20 plus 40. And how much part of it should I give to this 20 ohm? That is the 20 of it.
20. Yeah.
Yes or no? So
Yes.
just write the 20 over here. And what will I get? 60 by 60 into 20. So I'll get the 20 volt. Yes or no?
Yes. Sir.
Yes.
Now, what is the potential of D point?
40.
It will be 40.
It is 20 volt. So it is be again 40 volt. If this is 40 volt, what is the potential drop across these two?
40.
That is 40 volt because this is B point is at 0 volt and this is the 40 volt. So is this clear to you people that how I'm finding the potential difference at everything?
Yes, sir.
Next time in your examination, what the examiner will ask, he'll just apply the voltmeter here and ask you that tell me the reading of voltmeter. Is this clear to you people?
Yes, sir.
He'll do nothing and he'll just do this, that he'll apply a voltmeter here and will write the reading of V. So you have to go through this process only. Is this clear to you? Okay, if I
Yes,
apply
sir.
the voltmeter here, what will be the reading of voltmeter?
20.
Yes, it tells us about the potential difference. So it will give the potential or potential of these 2 points, the difference of potential of these 2 points, that is the 20 volt. Is this clear to you people?
Yes, sir.
Yes. Sir.
Okay, so this is how the things goes over here in this circuit. Okay, the same thing I can ask you again a lot of things. Tell me what is this current? I1.
Sir, the
Uh,
formula will.
Uh, which
so do
formula do
I?
you want? Tell me one
Yeah.
thing that across this resistor, do you know the potential difference across these two resist this resistor?
Yes.
Do
Yes.
you know the resistance of this resistor?
Yes.
So
Yes.
can you calculate the
So,
current in this using Ohm's law?
so it will be 2,
Oh yeah.
2 ampere.
Yes, it will be just 2 ampere. That's all,
Yeah.
and nothing else. No
Oh,
need to do the things of current divider here.
yes.
Current
Yes.
divider is actually used when you know the total current. Here
Yes.
we don't have the total current. Okay, do you agree that the same current is going to pass through this resistor as well?
Yes.
Just
Yes.
apply the same thing. What is the potential difference across this resistor?
40.
40
40,
volt. What is the resistance of this resistor?
20.
20,
20 ohm.
7,
What will be the current here?
2
That is
ampere.
again V divided by R, again 2 ampere. So can you see the same current is flowing through these two? They are in series
Yes. Sir.
actually. Understood?
Mm.
Yes, sir.
Now apply the what will be the current in this branch?
1.
1 ampere.
1 ampere. What will be the current in this branch?
1
One.
ampere.
1 ampere. What will be the current here?
3 ampere.
3 ampere. So are you people now comfortable with all these calculations?
Yes.
Yes, sir.
Okay. So for to find out the current, you just require the potential difference across the resistors and the value of the resistor. If you know about that, just apply the Ohm's law and calculate the things. That's it. Okay. So this is 3 ampere. Okay. Let me know. Actually, this was one of the thing which now what the examiner will do, instead of like asking it like this, what the next he can do, he can just connect the voltmeter and the ammeter across these 2 points, any point, and can ask you the several things about that, what will be the this thing, what will be this thing, and everything. Okay. So
Okay,
you
sir.
should be able to answer about that. Let me rub this all here, and no need of this, no need of this, need of this, this. Okay, what was the potential of D point? That was 40 volt. Okay, that was 40 volt. Okay, now tell me, if I ask you about the potential difference VCD, that is VC minus VD, what it will be?
It will be 0.
Yes. Okay, when I write it like this is actually the potential of those 2 points. Okay, so
Yes.
you will just substitute it 40 minus 40 and you will get the 0 volt. Okay, now tell me one thing. If I connect a resistor here of, let's say, any random value R, and I ask you about the current passing through this I, so what you will say, sir, I can calculate this I. The only thing which I require is just tell me the potential difference across the resistor. So I'll say that it is VCD. Yes or no?
Yes.
And the value of resistor, I need two information. So can you calculate this I?
Yeah. 0 and
What
3.
it is?
0.
Zero.
That will be 0 ampere. Understood?
Yes.
That will be 0 ampere, because current always forms higher potential to the lower potential. Their current flows due to the potential difference. Okay, it does not flows due to the potential. If whatever the potential is, if this is 1000 volt and this is also 1000 volt, okay, I had marked 10,000, this is also 10,000 volts, so no current is going to pass through it. Doesn't matter that how high the potential is, it actually doesn't matter here. The only thing
Yes.
which matters is that what is the potential difference. And here I can see the potential difference is 0. If the potential difference is 0, no current is going to pass through it. Is this clear to you people?
Yes, sir.
Okay, so this is something sorry, that how we used to calculate this I current. Okay, that means this resistor is actually it doesn't mean anything. What it does is,
Yes.
it doesn't mean anything. That
Yes.
whether I'm connecting it in the circuit or not connecting in the circuit, the circuit don't realize this resistance actually in it. Yet, yes or no?
Yes.
Yes.
If this circuit does not realize this, so if the next time somebody gives me only this circuit, that's it. Here it writes 10 ohm, here it writes 20, it writes here as 20 ohm, and here it writes as 40 ohm. And if he want to calculate the resistance across AB in that manner also, this is and let's say he writes a resistance to be 100 ohm. This 100 ohm is actually not giving any part in the resistance, because no current is flowing through it. Resistance
Yes.
is what? It is something which the charge is used to feel when the current flows through the when the current flows, the charge is used to feel that resistance. If there is no current flowing in this particular 100 ohm, so there is no actually the resistance felt by the charges. So what we can say over here, that whether this 100 ohm is present in the circuit or not present in the circuit, we can actually just what we can do, that we should just neglect it. We should not take care about that what the 100 ohm is, and we should Just apply the simple things and get the things. Understood? Is this clear to you?
Yes.
Yes, sir.
Okay. This is something that we should know about. Is this clear to you, people? And
Yes,
this
sir.
particular configuration is called the Wheatstone bridge. Okay. But Wheatstone, I think I'm writing the spelling to be correct. If not, just correct it by yourself. Okay. But whenever something, the Wheatstone bridge comes in our mind holds up to the four resistors. Four resistors immediately comes in our mind, and we used to imagine it the things like this. But my recommendation is that you should never think like to do the things in this way. Okay, let me give you a one question over here. Based over that, you will understand the things. Let me mark these resistors. Let's say it is 4 ohm, it is 8 ohm, and it is 12 ohm. And this is 6 ohm, 12 ohm, and 18 ohm. And this is 2 ohm, this is 4 ohm, and this is 6 ohm. Okay, this is here. And let me calculate, complete the write the voltage over here. Okay, and let's say this is the V voltage that I'm writing over here. And let me write about these resistors as well. Let me make it as 4 ohm each. Now, if I ask you about that, what is the equivalent resistance between A and B point? What it will be? Sorry. All these points are as same as A, so I'm marking it as A, and this point is B, C, D, F, H, same as B. Okay, how should we solve this? How should we tackle this problem?
Uh, the 4, 6, and 2 resistor will be in parallel, right? So just take
4,
it in
6,
Mm.
parallel.
and 2 will be in parallel.
Yeah.
Okay. How can you see? How can you say that 4, 6, 2 are they connected between the two nodes? Are they connected like this?
Oh, so the 462, it will be like vertically, not horizontal. Those ones.
It will be vertically.
No, no, like the first, so not the last row, like the first resistor in each row.
First
Uh,
resistor in each row.
can we take it like that or not?
What should I do with this 4, 6, and 2?
I don't think we can do it.
Okay. Can you people see here? See, this is all about the symmetry, that how better you can understand the things. Okay. So let me also see this R equivalent does not depend over this V battery. Okay. So whatever we assume the value of V here, that is not going to matter actually. Okay. Either you take it 120 or whatever it is. it's not going to matter. Okay. So let me take it as 36 volt. Let me take it as 36 volts. Why I'm taking this specific number to be 36 and how did I reach to this number? You'll get to this once we'll start doing the calculation. Okay, if this is 36 volt, so what is the potential of this point B that you can assume?
0.
0.
That will be the 0 volt. You can take anyway, but it is better to take 0 because marking the things with reference to 0 is easy. So that is why we used to do it. So this will be 36 volt, that means, and this same will be at 36 volt, and this will be at 0 volt. Is this clear to you people?
Yes,
Yes,
sir.
sir.
Okay, now tell me one thing, that if, see, actually what is here, okay, actually see, this thing all goes by hit and trial things, but as I had solved many questions, and how will you reach to this hit and try? That how should I get to know that I have to do this? How should I, so you'll because you are going to ask the same question to me 100 times. That how should I get to know that I have to do this? Because when I was solving this question initially, I also used to ask my teachers that how should I get to know. So the only answer is that just by practice you will get to know. There is no other way that you will get to know that I should do this. Okay, so what I am saying to you here is that let me not mark this point as B, because we had already taken the B, E, F, G. Let me take it as H only. Okay, so how will I get to know? See, what is actually here, that the potential of H point, the potential of C point, and the potential of D point are all same. There is no potential difference between H and C and between C and D. As a
Yes.
result, there will be no current in this resistor and no current in this resistor as well.
Yes.
Yes.
How can I say so for sure? See, the only thing that I can do so for you right now is that just take this circuit, okay, and let us do one thing, that just paste this circuit over here, and let us assume that the potential difference is actually zero. If we'll assume the potential difference is zero, what I can do so that I can remove these resistors,
Yes.
yes or no? And now let us calculate the potential of H, C, D, E, F, and G. If we get the potential of H, C, and D to be same, that means our assumption was correct, that there is no potential difference. If we get the answer to be different, that means our assumption was wrong. There is some potential difference, and we need to take care about that. Is this clear to you people?
Yes, sir.
What right now I'm assuming is that I had got an intuition that there is no potential difference. And how I am getting so, I'll tell you, but let us first of all calculate all this. Okay, so tell me, if I want to calculate this VAH, so what will be the potential? VAH,
VH will be, it will be,
what is the
Uh,
potential drop, total potential drop if we move from A point to B point?
36.
That is the
yes.
36. So
So
take the
just normal
36.
viewer or normal viewer, sorry.
36, in how many parts do I need to divide it? 4, 8, and 12. Yes or
Yes.
no?
Yes.
Yes, sir.
4 plus 8 plus 12. And if
Total.
I'm calculating the potential difference across AH, what should I multiply here? That is the
4.
4. So what will I get? 36 whole divided by, what is the sum of it?
It will be 6 total.
24.
24.
24 into 4.
6.
So that will be 6 volt. Yes or no?
Yes.
Yes.
If I calculate VHE, so how much it will be?
36
Can you
by.
see that if there is the potential difference of 6 volt here, so here it should be 12 volt, because if
Yeah.
we used to
Uh,
divide the potentials with respect to the
Yes.
resistors. if it was previously we were giving the 4 unit to it, this time I need to give 8 unit. So it will be definitely 12. And what it will be?
Here it will be
The 3 times of the first one,
so it will be
18.
yeah
18.
18. 18.
The 3 times of the first one. Same is the things going on here. Understood? Is this clear to you?
Yes, sir.
Now
Yes, sir.
let's calculate that the first point is 36. What is the potential of H point?
6 volt.
H point,
Sir,
this is
sir,
the
what
potential
is the
difference.
potential? What is
12.
30.
30?
Because it was 36, A point is at 36, it should drop by 6 volts. This is at 30. What is the potential at E point? It should
will
further
be
drop by 12 more.
to
Yeah.
18.
18. What is the potential difference across this? That is 18 that we already had
18.
calculated, and by this also we are getting same as 18 volt. Understood?
Yes, sir.
Yes.
Let us see. So let me write it over here. VHE we calculated as 12 volt, है ना? And VEB we calculated as 18 volt. Okay, let us do this analysis for this branch, this middle one branch. If we want to calculate VAC, yes, Rajan, what should I write here?
VAC, total volt by resistance 6 plus
Yes, so
12.
36 is the one. What should I
Yes.
write in the denominator?
6 plus 12 plus 18
6 plus 12 plus 18.
into
And
6.
how much part of it do I need to give it to 6? That is the 6 of it. So
6
what will I get over here? That is
So
36. I think in the denominator is also 36. So I'll get the 6 volt here.
6 volt.
Yes or no?
Yes, sir.
So the potential difference across this is 6 volt.
6 volt.
What will be the potential difference across this?
12.
12 volt. What will be the potential difference across this? The 3 times
18.
of the first one. That is the 18 volt. Again, the potential difference across this. Let us again do the calculations over here. Okay, let me write it here only. Don't want to scroll it up and down again and again. So
6.
36 divided by 2 plus 4 plus 6 and multiplied with the 2. Yes or no?
Yes.
So how much
Will be 6.
will I get here? That is 6 again.
6. Yes.
Yes.
That is the 6 again we are getting. So that is again 6 volt. How much of it? The double of the first one. Yes or no?
Yes.
That will be again 12.
12.
And this is the 3 times of the first one. That is 18 volt. Okay, let us mark the potential of the points. If this is the potential A is at 36 and we are dropping by 6 volt to get the potential at C. So what is the potential at C?
30.
30.
30. What is the potential at point F?
18.
18.
Further drop it by 12 volt. That is 18 volt.
18.
Okay. Same. What is the potential at D point?
30.
30. What is the potential at G point? Further drop it by
18.
12. That is 18.
Hmm.
And you can see it otherwise also. In the last branch, we are getting the potential difference of 18 volt automatically. Okay. So this
Yeah.
means this circuit is totally correct and we had marked everything to be in a very correct manner. So can you see that potential of H point is same as potential of C point is same as potential of E point.
Yes, sir.
Sorry, potential of D point actually, the lower one. Is this clear
Yes.
to you people? So that means we can actually, there is no use of these green resistors that are 4 ohm, 4 ohm, 4 ohm and 4 ohm. And we can same verify it for the E, F and G point. All are at 18 volts. Yes or no?
Yes.
Yes, sir.
So what we can write here, that potential of E point is same as potential of F point is same as potential at G point. Yes or no?
Yes, sir.
This is something that we saw here, and this was something that we had assumed first, and then we verified it that yes, that is the true thing. Understood? Is this clear to you people?
Yes, sir.
Yes. Now, if somebody asks us now the R equivalent, now we can calculate it. What is the RAB? If somebody asks me the RAB, so I'll say that the 3 branches are in parallel. Yes or no?
Yes.
So what I can write here in the first one, that is 4 plus 8 plus 12 are in series. That's why I added them. This is in parallel with 6, 12, and 18? Yes or no?
Yes.
Yes, sir.
And this is in further parallel with 2, 4, and 6. Yes or no?
Yes.
Yes, sir.
What will be the first one?
Twenty.
Should I write it as 24? Is in parallel with. The second is
36.
36. Is in parallel with.
12.
12.
Which is others? 12. 12. Okay. So this is something RAB. And if you further want it, I can do so. But you should do it by yourself. This is 12. What will be the LCM here? 36.
Uh,
What will be here? Uh, I think
no.
2.
Uh,
No, 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 no,
It
no.
will be 1. It will be 3.
the LCM will be 72.
Sir, it won't be
Oh, you're doing
24.
okay, okay.
Just do it in any way that whatever you like. 36. Had I
It will be
committed a
72 by
mistake?
11, right?
No,
72 by
no,
11.
mistake, sir.
Yeah,
Mistake.
LCM is
Yeah.
72.
What is the first one? LCM is
72. 72. There's no common.
okay. Let me do it in a somewhat different way that you had 24 now. So
The multiplication.
okay, what is the answer?
72 by 11.
72 by 11. So
Yeah,
okay.
yeah.
Yes, now maybe I'm believing on you. RAB is 72 by 11. I not calculated that. 72 by 11. So this is the final answer. Is this clear to you people? Yes or no?
Yes.
Yes,
Yes, sir.
but
Yes, sir.
one thing that you must ask here that nobody said to me, but I'll say by myself. What I had made a statement here that if the points are of at the same potential, I can actually join those points. Yes or no? If
Yes.
the points are having the same potential, so I can join those. So the above circuit can be realized in the same manner. Let me name it as method 2, in which the first three resistors are connected like this. The second three resistors are connected like this. And the third three resistors are connected like this. Can I write it like this as well?
Yes, sir. That's what I tried saying at the beginning.
Because if whatever the potential of this H, C, and D are the same points actually, because they are having the same potentials. So I can write 6, 4, 6, and 2 to be in parallel. Yes or no?
Yes, sir.
Oh, yes, sir.
So that's what I meant
H,
in the beginning when I was trying to say, can we just join the vertical
yes,
words together?
8, 12, and 4. The next is 8, 12, and 4. Write the unit by yourself. Okay. 12,
Okay.
18, and 6. Okay. So if we want to calculate the resistance of the first branch, okay, so what will be the resistance of this whole?
Uh,
Calculate it.
3 by 4, I think.
It will be
Uh, mm, mm, 4 by 3.
4 by
Yeah.
3.
I don't know. That's what I wrote before, but
Yes, both of you verify each other. Okay, calculate the second one. No, it will not be 4 by 3.
The first one will be 12 by 11. Second one,
12 by 11.
11.
The second one will be
Oh, yes, sir. Okay, I didn't. Cos. The second will be 24 by 11. Yeah, 36 by 11.
Okay, so is this clear to you people?
Yes.
Then what will be the RAB here? That will be 12 by 11 plus 24 by 11 plus 36 by 11. And if we'll sum them up, we'll get the same answer, 72 by 11. Yes or no?
Yes.
That we got in the above case also. So this is something that you should know about whenever we are calculating the things like this. Is this clear to you people?
Yes, sir.
So,
Okay.
sir, do we need to prove that the points are like of the same voltage?
Yes, they are at the same voltage. That is why actually we are able to
Yeah,
join them.
yeah, but like, do we need to prove that well, drawing is right?
Oh,
Like, do we need?
you see what you can say over here by the symmetry. If you are asking about that, how will you write this in examination?
Yeah, do we need to write all
In
that points like where is
yes,
the same
you
thing?
can instantly, you can immediately make this statement that potential of H point, C point, and D point are same, and potential of E point, F point, and G point are same. Therefore, this 4 ohm can be removed actually.
So we don't need
Okay.
to do this. We don't need to find the potential at
No,
that
no, no,
point.
no, no,
Uh,
no. Until and unless the question asks you to do so, first of all, the question will never ask you to find the potential until and unless he had specified one potential in it. Okay.
mm,
If he had made the ground like this, then he may ask the potential of the point because this time he is already giving you the potential of 1 point, that is the 0 volt. Okay. If
yes.
he had not given this, so he'll always ask about the potential difference. Okay. And if he asks the potential difference, you can calculate in this fashion.
Uh, so otherwise, just
Okay.
simply.
Yes.
Uh,
Okay. But I had just shown it to you for to make you realize that this is the
yeah.
first time you are going to see somewhat like this. Is this
Yes.
clear to you?
Yes.
Okay. One more thing for the something to be in Wheatstone Bridge. Let me write it over here so that see actually how I was getting to know that they are immediately they are having the same potential drop. The reason behind that is see in the first branch, can you see the resistances are in the ratio of 1 is to 2 is to 3.
Yes.
In the second branch as well, you can see the resistances are in ratio of 1 is to 2 is to 3.
Yes.
In the third branch as well, you can see the resistances are in the ratio of 1 is to 2 is to 3.
Yeah.
So actually, the potential is going to be dropped by the same ratio, that is 1 is to 2 is to 3.
Mm,
And you can see that in the first part, the potential is 6, 12, and 18. That is the 1 is to 2 is to 3. Yes or no?
yes. Yes.
So this is something that we had seen over here that just by getting by knowing about this, that they are going to get by drop by the same ratio, and as a result we are going to get the same potentials at point H, C, and D. Is this clear to you people?
Yes, sir.
Yes.
Okay. So if R1, R2, R3, and R4, and let me make this as R5. If R1 by R2 is R3 by R4. Or the reverse wise, what I can write here, that R1 by R3 is R2 by R4. If I can see this, I can specify. See, the first one statement or the last one is the same one. I just
Yes.
replace the R2 and R3 by each other, that we can simply do by cross multiplication and everything. Okay,
Yes.
so if we can specify this, so what we can do is we can substitute this above circuit by only 4 resistors, that are these 4. We can actually remove the R5. Okay, this is R1, R2, and R3 and R4. Is this clear to you people?
Yes, sir.
Yes, sir.
Uh, And actually, the potential of this point and this point is same. So it is need not to be necessary that you should replace the above circuit by this part only. There is a very good possibility that you can replace the above circuit by this fashion as well. Do you people agree with this?
Yes.
R1 and R3 will be in parallel, and R2 and R4 will be in parallel. Is this clear to you people?
Yes,
Yes.
sir.
So you should know about all these tactics. Understood? Yes, understood.
Yes, sir.
Okay.
Uh,
Yes. Any questions?
so we can do R2, no, R3 and R4 in series as well, no? Is R3.
R3 and R4 is in series. Yes, I had done that.
Oh,
R3 and R4 are in series,
mm.
and R1 and R2 are in series in the
Oh
above
yeah,
branch.
yeah. Oh, yeah.
I just pick the R5 and take it out from the circuit. So
Mm.
what will I get? I'll get this circuit. But
Okay.
instead of doing so, I can do this way as well. This is something that you will get all over the internet and everything. Everybody used to say, tell you about this, but very few of the people will tell you about this particular thing. That is, we can even make R1 and R3 in parallel as well. The reason behind that, because they are having the same potentials. Is this clear to you people?
Yes, sir.
Okay, so do you people want to do a good question?
Yes.
Okay, let me give you a first easy one. See, actually, this is the favorite topic of any competitive examination or any school examination as well. One question will be definitely asked to you based over this particular thing. This is 5 ohm, this is 6 ohm, and this is 2 ohm. And this is 5 ohm, this is 4 ohm. है ना? Yes. And this is A point, and this is the B point. Tell me the RAB. Sorry. Yes, did you people got the answer?
One second, sir.
See, maybe while doing the course, I'm moving a little slow, and but whatever we are doing over here, that is of having a very good quality. Okay,
Yes, sir.
and I think that we should always prefer over quality over the quantity. See, even if few of the chapters like magnetism and matter and like few others are there, what is there? That is the EM waves. Okay, so all these chapters are somewhat like that. Uh, I should not do here. You can do it at your own. That are some of the very easy topics. So if you can do that, do those chapters at your own, so we can use our class in an efficient way. Okay, because we already have a very limited number of classes. So that's why I'm trying to do like see I can do only this much in the 1.5 hour. Okay, so just
Okay.
try to do that, not to cover those basic and all those chapters to be here in the class. Yeah, already there is lot of sources where you can do that. Just do that. Okay, so did you people got the answer?
One second, so just one second.
Yes, Regent, how did you tackle this question, first of all?
I took it 6 ohm and 2 ohm as a parallel.
Exactly. Yes, you are absolutely right.
Is it like okay then I wrote is 5 ohm is like 5 ohm and whatever I got the value of from like parallel of 6 ohm and 2 ohm, and I took it 5 ohm and the value I got from basically yeah, how do I say, see this is what I got from 6 ohm and 2 ohm parallel I got like 3 by 2 resistant.
Okay. Yes,
Then
okay. You solved these two in parallel, you got the
yeah,
answer. Then,
yeah, I got it as 3 by 2. Then again I took it as like parallel like 5 ohm and
yes,
6 3
exactly.
by
Actually,
2.
these three are in parallel.
Yeah,
Okay.
yeah,
Then,
that's what I did. Then again on the right side there's 5 ohm
yes,
and
these
4.
two are in parallel. Exactly.
Yeah, then
Then
like
the total
then
combination is in series.
yes,
Understood, Ahil? What I can do over here,
Yes, yes, yes,
let
yes,
us
but the
mark these points A, C, and B. What I can say here, that a 5 ohm, this 5 ohm is connected between A and C. So just connect it in between A and C. What I can see over here about this 6 ohm, this is connected between A and C. Just connected in between 6 A and C. What is this 2
Hmm.
ohm connected between? Between A and C.
So,
It's connected between
is
A and C.
the final answer 1580 by 468? But I didn't simplify it. Yes, sir, I got that exact diagram. Final
Okay.
answer I'm
This is
getting
also
one
5
five.
ohm and this is also 4 ohm. The
Yeah, I'm
final
getting
answer, let me see if
one
I
five eight
had.
zero by 468. But I didn't simplify it yet.
Sorry.
77 by 30.
Okay, so
Uh,
6 is R1. What is the combination of the first 5, 6, and 2 you got?
Sir, what I had done was I combined 5 and 6. Then
Yes,
I had
and then
taken
combined with
and
the
then
2.
taken the combination like how we did before. Like combined 5 and 6, then the equivalent with 2,
Just a
then the
second.
other
Let
one
me
in.
write it over here. 5 is in parallel with 6 is in parallel with 2. They are further in series with 5 is in parallel with 4. Is this clear to you people?
yes.
Now solve it at your own. Okay. I don't
Yes, sir.
require. You can solve this combination. You can solve this combination, add them up, you'll get the answer. Is this clear to you?
We, sir, could you just check the answer 1580 by 468?
I have not written the answer here. Okay. If you want me, let us name this as R1. So 1 by R1 will be 1 by 5 plus 1 by 6 plus 1 by 2. That will be the LCM of these three. That will be 30. Okay. And 6
Yeah,
plus 5 plus 15. And it will be 15 plus 5, 20, 26 by 30. That will be 13 by 15. Okay. And if you want to know about R2, so that will be 5 into 4 divided by 9. So that will be 20 by 9. And if you
yes, sir.
want to know about RAB, so that will be 30, not 13, 15 by 13 plus 20 by 9. So just do it. 13 nines are 117 and 15 nines are 135 minus a plus of 20 to 30, that is 260.
Yeah.
And if you further add them up, 117 and 395. Okay, so this will be the final answer. And see if I had committed any mistake, so just correct it by yourself. Okay, so this was one of the question. Let me
Thank
give
you.
you one more question. Let us say this is the X point A resistor is here
P.
looking like this. One more resistor is there looking like this. One more resistor is there looking like this.
Oh
And
yes,
one
sir.
more
Sir,
resistor is there.
I had gotten 1580 by 468, but then if you divide the whole thing by 4, you'll get 395 by 117.
Okay, let me write it over here. 395 divided by 117. It will be P
I
point
didn't simplify it, so I got
376 ohm. Okay,
yes.
just check it by yourself. Now this is the final answer. Moving on to this. This is and one more resistor is here. That is this, and that's all. R. This is also R. This is also R. Yes, everything is R. This is Y point. Calculate the equivalent resistance between X, Y. Do it fast. Okay, I have two more questions. We'll finish it here in this class only. Do it fast. Let me see. R, R. Yes, everything is right. Okay. See, always remember that you can squeeze the wire anytime. Okay. Wherever the long wires are there, if you want to squeeze them up so that you should get a good visualization of that picture, of that image, so you can squeeze that anytime. Okay, did you people got the answer?
One second, sir.
Okay, how are you people approaching this problem?
Sir, it'll be one resistor, then it'll break into two other parallel resistors, right? Like
Okay, let me now mark the points over here. Let me mark this point to be P, this point to be Q, and rest all the points are already known to me. This is also Y, this is also Y, this is also Y. Yes or no?
yes,
This is same as Q. Okay, so every point is being marked. Now let us place the resistors over here. Let me place the P point here and Q point here. So what can I say between P and Q? There is a R resistance connected.
yeah,
Yes or no? From P point, there is a point X. And in between P and X, there is a R resistance connected like this. Yes or no? And
yes, sir,
in between X and Q, there is one more resistance. Let me mark this point as X. So in between X and Q, there is one more resistance R marked over here. Yes or no?
yeah,
Now, below P and Q, there is one more point that is Y. And in between P and Y, we can see this resistance. So let me place this resistance here. And between Q and Y is also there is one resistance. Yes or no?
yes.
So,
Uh,
and what is between X and Y? There is one resistance that is X and Y connected like this between X and Y. So let me make it from this side. And we want to calculate the resistance between these 2 points, X and Y. Yes or no?
yes,
So did you people saw that how we transform this circuit into this good looking one? Yes or no? So
sir.
can you people see that this is totally waste? Because if we'll apply a battery over here, whatever the potential drop will be at this side, the same will be at this side, the same will be at this side, and the same will be at this side. So P and Q are at the same potentials. Yes or no?
Yeah.
Yes.
Yes,
Yes.
sir.
Potential of P point is same as potential of Q point.
Viewpoint.
Okay. So how what should be our next thing? That let us what next to do? Just this,
It's,
this, 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 and uh,
yes,
a resistance is looking like this. Is this clear to you?
yes, sir.
Sir.
So
This is
final
X1,
will just be R.
R, 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 and R. What can we say about this total combination? This will
Yeah,
be 2R,
yeah,
and this will be again
2 R.
2R. And the common of these two 2R, 2R is nothing but R by R,
Just R.
and
Yes,
this is also R. So this is
yes,
also R, this is also R, this is X point, and this is Y point. And what is the equivalent between X and Y? R, X, Y. That will be
yes,
R by 2.
yes,
Understood?
Yes.
So
yes.
this is how we are solving these things. Okay. Let me give you one more. Let me mark this point as P and this point as Q. Okay. Each side, actually, these are the two switches, S1 and S2. Okay. And what I
Mm,
can say that each side is having resistance as R ohm. Understood? And these switches are also in itself a resistor. Okay, so instead of making it like this and this again and again, I just drawn it with a single line. Understood?
okay,
Okay, so the and switches in itself is a resistor or of R ohm. Okay,
yeah, yes, sir.
okay, now what is your aim is to calculate the R before switch is closed, S1 comma S2 is closed like right now, and the ratio of R after switch is closed. This is the figure right now. Calculate the resistance right now, and once the switch will be closed, then calculate the resistance.
Sir, each side having resistance R as in,
Each
what is that?
resistance, each side is having the resistance R.
Oh,
This branches in itself is a resistance R. Okay, but
oh,
as the time till the time it is open, so it will not come into the expression of the resistance.
yes, sir. So when switches, when switches open and after,
Yes,
so when switches open, it'll
switches.
just be a series circuit, right? The whole thing will be in series.
Exactly,
It'll just be,
exactly.
yeah.
Till the
So,
time the
Sir,
switch is open, the current have only the option to flow like this
mm,
manner
the
only.
5R.
yeah,
Okay, so 5R will be the answer for that. And but what if once the switch is closed?
then it'll be
It is
like
5R.
Wheatstone in the middle, yeah.
Exactly.
Which
Yes,
one?
that is something that is going to happen over here. Yes, Rijan, did you got understood that what is happening here?
Yes.
Yeah.
Till the
The
time
series.
the switches are open, the resistance will
Mm.
be somewhat like this,
Yeah,
in
that I
this
So
fashion,
understood.
will answer be
and you can
5 by 3?
simply add them up. Yes, yes.
5 by 3 will be the answer.
Uh,
No, no, no.
After closing,
No, 1 second, sir. 1 second.
I don't know what is happening here. Yes. Yes. Once the switch is closed, then what will happen? The picture will look somewhat like that. This is the
Which
R resistor. This is one, and this is one. This is one. The resistors will look somewhat like this, and these are the 2 points P and Q. Yes or no?
Yes.
So can you people see the Wheatstone bridge here?
Yes, sir.
Because the potential of this point and the potential of this point is same. Because whatever the drop is going to be at this side, and whatever the drop is going to be at this side, this will be the mid of that, the half of that. Yes or no?
Sir, so final answer is 2 is to 1.
Let me see. Once, so what you can do simply over here. Let me copy paste it again. Once you will get this, what you can do, you can remove this R from between. Now, uh, uh, it's a very easy problem. R and R, this will be together
Yeah.
2R, and this and R, this will be together 2R, and this whole 2 by R together will be what it will be,
R.
R. And
R.
now can you see that this R,
So
uh,
5 by 3. 5 is to 3, sir. Yes.
R
this
resistor.
R,
Yeah.
this R, and this R is in series. Yes or no?
Yes.
So it will be PR basically. So what
Yes.
we can say, PR. And this is our final answer. Okay.
Yes.
Ajay, tell me one thing. If I take a very bulky circuit, like somewhat like the resistors are connected somewhat like this, and all other. Okay. Anyway, P and Q. If I connect these 2 points like this, now if I ask you the resistance across PQ, what it will be?
Oh, R.
Let me make a good for you. Yes. Now tell me,
R.
Oh, it will
what
be
will be
R.
the resistance this time? Let me
R by,
make it
R
in
by 2.
more proper way.
No, no,
Okay.
no, wait.
R by 2.
Yes. It will be
R by 2.
R by
No, no,
2.
R, R, sir. Just R.
R.
Just R.
Yes, yes, yes.
Yes, Region, what do you say?
Yeah, I said R only.
The same
No.
as R. The answer is 0. Okay.
So there's no
Just
battery.
yes. Just go and think about it. That why the resistance between PQ point is 0. Okay. The answer is 0 ohm actually here. Is this clear to you people?
Yes, sir.
Okay. So just we'll see that why it is 0 in the next class. But take it as an assignment that solve it at your own that why the resistance is the 0 ohm in this case. Okay. And I think this is all about our today's class. And we had seen a lot of questions today and a lot of expressions, different kind of circuits and everything. And I hope it's all clear to you. If there is any doubts,